Hello, everybody, and welcome to another Mystery Box Function Challenge. Today is the 364th challenge out of 365. So we've got a particularly tough one for you today. If you'd like to try this out on your own, use the link in the description. And when you've got an idea about what the secret mystery math is inside this purple box, come on back and see if we get the same thing. All right, let's start with a 0. Oh. So 0 is not a number, and sometimes we get not a number when we have the square root of a negative. Sometimes we get not a number when we have a removable discontinuity in a rational function, and sometimes we get a not a number when the bottom of a fraction equates to 0, but usually with some other calculation going on, so it could be a rational function for that reason too. All right, so a lot of possibilities here. Let's try a 1. Okay, so that looks like a non-repeating decimal. How about a 2? And another non-repeating. I'm going to try 3.14 in case this is trig. Maybe that'll give you something good to look at. And that is pretty darn close to 0. So that is making me think trig. It's actually making me think sine might be involved somehow. Let's continue on, though. Oh, seems to be getting much more shallow as we go along here. Yeah, it's definitely coming back up again. So the trig hunch is confirmed. Let's do something closer to 0. So let's do 1/2. And let's do 1/4. So it doesn't look like the behavior around an asymptote. So maybe this is some kind of removable discontinuity or some point where the function is just not defined, but otherwise it's continuous around it. Let's try some negative numbers. I'm going to start with a negative 1/4. Oh, interesting. So there's a jump there, and a negative 1/2. Are we going to get symmetry here? Yeah, it does look like it. Do a negative approximation for pi. Okay, so I think we have enough points to reason this one out. It is an odd-looking one. We have seen something like it before, and once upon a time we had the sine of x over x, and what that did is it made what looked like the sine wave right around 0, and then it just got shallower and shallower as it went on, closer and closer to just hugging that x-axis. It looks to me like this is doing the same thing. So it starts up here near 1. Actually, it doesn't start there. It's undefined at 0, but it looks like it starts there at 1. And then it goes down to 0 like you'd expect it to, but then it only dips up a little bit. And my guess is it's going to get shallower and shallower as we go out. So let's actually put in a few more values there. Let's put in an 8 maybe and a 9. Yeah, so you can see these numbers are just getting closer and closer to 0 as we get out. So that looks a lot like the sine of x over x. However, not over here. It looks like the mirror image of the sine of x over there. And when you have a break in continuity right at 0, sometimes that means what do you call it? An absolute value is involved, especially when you get that mirror image on the left and the right. And where I'm thinking that's happening, yeah, where I'm thinking that's happening is here, right? Because then if we put in a negative 1 down here, it would become 1. You get the sine of x over 1. Yeah, is that right? Yeah, I think that's going to be right. It does seem to work with the other points, at least in my head. Of course, at pi, you're going to get 0 over pi, so that's going to equate to 0. And then it should, as these numbers get bigger, it should uh, make everything closer and closer to zero, bigger positive or negative, and then um, yeah, I think this has got to be it. Let's go ahead and take a look. Maybe I'm off here. No, that's the sine of x over the absolute value of x. So, I didn't have a lot of points that I was going to test there. It was the mirror image that made me think this had to be the absolute value of x under there. Let's go ahead and graph that. Yeah, so you have that sort of undefined point at zero with the discontinuity in the graph, and then the graphs of the sine getting shallower and shallower as you go out. Well, I think that was super, super hard. You would need to have recognized the sine of x over x. That would have put you in a good place to understand this one, and then figure out that you need an absolute value in there somewhere to get that left-right sort of mirror image. Well, tell me what you were thinking. I'd be curious to know. Thanks, everybody.